In this video, we're going to look at why we can add zeros when multiplying whole numbers by powers of 10. So for example, let's say you have the number 4,000 and you're multiplying that by 80,000. You've probably already learned that you can do 4 times 8, which is 32, and then just count the number of zeros that you have here, 1, 2, 3, 4, 5, 6, 7, and put on 1, 2, 3, 4, 5, 6, 7 zeros, and then go backwards and put in our commas, so we get 320 million. Now technically you aren't adding zeros, because when you add 0 you don't change the value of a number, and clearly we've changed 32 into a much larger number. Technically what this is appending zeros, which means adding zeros onto the end of a number. But semantics aside, let's look at why this trick actually works. Our first factor we can think of as 4 times 1,000. And our second factor we can think of 8 as 8 times 10,000. And I put these in parentheses just to make it clear that we have 4 times 1,000 is 4,000, 8 times 10,000 is 80,000. We can then break them up even farther and say that 4 times 1,000 is the same thing as 4 times 10 times 10 times 10. Because this part right here, 10 times 10 times 10, that's really 1,000. I can do the same thing with the 10,000 here. I can think of this as 8 times 10 times 10 times 10 times 10. Because this part right here is really 10,000. So what I've done is I've written this in a very expanded form here. I've written 4,000 right here times 80,000 right here. This would never be how I would actually write this problem, just because it takes a long time, but it is equivalent to our original problem. And the associative property of multiplication says that when I'm multiplying a big long string of numbers, and it's all just multiplication, I can group those numbers however I choose, and which means I could group the 4 times the 10 here first and do that first, and then do the 10 times the 10 second, and then do the 8 times 10 third, and then do 10 times 10 fourth. Or I can combine the associative property with the commutative property, and the commutative property allows me to rearrange the order. It means I can flip them around. Instead of doing 8 times 10, I can do 10 times 8. Instead of doing 4 times 10, I can do 10 times 4. So in combination, the commutative property and the associative property basically allow me to group and rearrange all of these factors right here in whatever order I want. So I think I'm going to regroup them into 4 times 8 first. Because I know 4 times 8, that's 32. I can do that fairly easily in my head. And then I'm going to group all of the 10s together. So it looks like I have 1, 2, 3, and then I have 4 more. 1, 2, 3, 4. So this is the commutative property and the associative property that allows me to do this. So I know that I have now 32 times 1, 2, 3, 4, 5, 6, 7 powers of 10. Now let's take just a second to think about place value for a second. Let's say that I have the number 5, and I want to multiply the number 5 times 10. I know that that's 50. And if I want to go back to my original number 5 and I want to multiply it by 100, I know that that's 500. And if I go back to my original number and I want to multiply 5 by 1,000, I know that that's 5,000. Now, after every one of these numbers, there actually is a decimal point that is hiding, because a decimal point just separates whole numbers from parts. And after the whole numbers, in this case, there are no parts, so there would just be zeros in all those place values. But what I can say is happening is that every single time that I multiply by a power of 10, I'm taking my digit here, the 5, and I'm shifting it over. It wasn't the ones place. I'm shifting it over one place value to the left. So I'm shifting it to the hundreds or the tens place, then shifting to the hundreds, then shifting it to the thousands, and I'm filling in all the empty place values with zeros. Anytime we multiply by a power of 10, we shift our digits to the left. So going back to my original problem here, I have 32 times 7 powers of 10. I could write this as 32 times 10 to the 7th power. That means 7 powers of 10. So I need to shift 32 over 7 place values to the left. Well, I do that by filling in all of those place values that I'm shifting it over with zeros. 1, 2, 3, 4, 5, 6, 7. And then I can go ahead and put in my commas to make this a little bit easier to read, and we have 320 million. So when we multiply numbers that include powers of 10, we can look for easy base problems or easy digits so we can do in our head, in this case 4 times 8, which is 32. And then when we're going through and we're counting the number of zeros and we're quote unquote adding zeros to the end of our original base problem right here, what we're really doing is we're figuring out how many powers of 10 we need to shift our digits to the left. And then when we add zeros or append zeros, we're actually shifting those digits to the left and filling in empty place values.